Hi guys, welcome back. I wanted to just sum up in this part 3 a little bit of what we looked at in parts 1 and 2. Really just to solidify what is a VLAN, the idea of a broadcast domain, the idea of access ports, trunk ports, and then just to take a quick look and verify and observe the traffic crossing that trunk link again. You might also notice I've added in one added extra there, a VLAN 99. And I've put an IP address of 192.168.99.5, and this is just to signify that what if an IT manager wanted to access the switches remotely, for example. And what we might demonstrate is just quickly using the telnet protocol, even though it's an insecure protocol, just to show and really just to showcase a user logging in remotely, so they don't need to be standing beside the switch with a console port. So as you know, I have basically we had different broadcast domains in. We had our VLAN 10. So again, any broadcasts were now just limited to this broadcast domain, and we also had our faculty VLAN 20, and we put this other guy in VLAN 20 also, and we ensured that we gave it an IP address of 192.168.20.5 and 20.3 being a /24. So one last thing that I wanted to quickly show you was in the last video, I wanted to just walk through with you just doing a simulation again from PCC over to PC0, and let me just open that up and delete these last few. Let's go back to simulation mode and let's try that once more. I just wanted to demonstrate these tags again, which you're just walking through one step at a time. So essentially, once I click on go, I'm going to click on the envelope and I can see the inbound and the outbound. And remember, this is just the ordinary Ethernet 2 frame that's coming into the switch here, but on the way out, it's basically tagging with this VLAN tag. So essentially, let's just pop that back out so we can see it. But essentially, we see that the tag has changed. Now, in the last video, I was selecting this, and that was by accident. Apologies for that. But it was actually, this is the key tag here. Okay, this is the tag control identifier. And essentially, we can see in this case, it's got a 0x0014. And once again, if we bring up our calculator, let me just bring up our calculator there if I can. Let's try and find that so we can quickly bring that up in front of us. And if we just select that again and bring back up our calculator to just make sure that we type in the right number. So it was basically, if I go back into hex, it was 0014. Was not it? And if I bring that back to decimal, we can see that this gives us a value of VLAN 20. Okay, so essentially that's essentially it. Let's just move that over so we can see it. There we go, 0014. Okay, so again, once that goes across the tag link, it would essentially move across here. It would rip off the tag and essentially it would pass it on to the computer. Computer would send it back. The switch 1 would now add a tag. And again, if we double click in here and we see the inbound, there's no tag. But when we go back to the outbound, we can even see here that it's identified as 802.1q. And obviously here is the same tag again going out. It'll go back across there and hopefully we should see a green tick, which we do. So we are successful. So that's our, if you like, tagging. And hopefully you've got a good idea of the tags being added on there. Just to do a final check, just so that we're extremely clear on this, let's just do one last one between PCB and PCA. Again, in this case, because PCB and PCA haven't talked to each other in a little while, the ARP cache no longer has the IP to MAC address translation in its lookup table, or in its ARP cache, so it has to basically ARP for that. And you'll notice here, there goes the ARP, it goes across, this guy replies, PCA, now PCB has that, so now it can send a message. And this is the ping message, obviously, the ICMP. Once again, we've got an inbound, again, normal Ethernet frame. Outbound, we see this, for example, 802.1Q, and it's not the type, it's this one here, isn't that right? The TCI, and it's ending in an A. And we said last time when we brought up our calculator, when it ended in an A, let's just bring it back here and let's clear this guy. If it ends in an A, and if we put that back to decimal, it represents VLAN 10. So again, going across here step by step, we'll be able to see this going and moving across, and we should be successful. So the last thing I wanted to show you guys was this whole idea, what if I added a new manager, an IT manager that was going to manage this network that needed access. So it may not be a good idea to keep these on the same student network and also the faculty network. It might be good to segregate and to separate this out completely. So what I've done is I've created this at this moment in time, just an IP address, 192.168.99.5. And essentially now what I need to do is I need to create a new VLAN on this switch. We'll also need to set up a VLAN number of 99 so that we can actually access this switch. Because if, for example, I was at this PC now and I went to ping, for example, let's say ping 192.168.99.5, of course this is going to fail because, again, I'm in simulation mode. Let's go back to real-time mode. But, oh, hold on, let's try ping. Sorry, my apologies, I'm pinging myself. I want to ping, for example, a switch. Now, at the moment, the switch doesn't have this basically IP address. So what I would need to do is, and that's going to time out 4 times, I would need to go into this switch. I would need to put this port, create a new VLAN, call it 99, put the port 5 as a switch port access, and then put an IP address on here. So let's do that really quickly. So we can see that we've got our 2 VLANs. Let's set up a new VLAN very quickly. So I'm going to go VLAN, I'm going to say 99. I'm going to name this IT management. And then what I'm going to do, it doesn't like the fact that I've got a space by the looks of things here. So let's just pop in there an underscore. That looks like it's accepted that fine. So let's ensure that it's accepted that name. There we go. VLAN 99 is in there. I'll now need to move that switch port of switch port 5. I want to move that down to 99. So I'm going to do that now. So I'm going to literally go conft. I'm going to go interface fast ethernet 0/5, and I'm going to go switch port access VLAN, and I'm going to say 99, and I'm going to finish that off with forcing it to become an access port. Now, what I need to do now is I still don't have an IP interface, a layer 3 interface. Now remember, these switches are acting as layer 2 switches, but in order for me to ping them, I need to have a virtual interface. So what I'm going to do now is I'm going to say conft, I'm going to say interface VLAN 99, and then what I'm going to do is I'm going to say IP address, and I'm going to give it that IP address of 192.168.99.1, 255.255.255.0, and I'm going to say no shut. And what this should do is it should essentially bring this interface up. And when I go show IP interface brief, I now have this VLAN 99, and we can see it's in an up condition. So I can now go back to my PC and I can ping, and hopefully now we should start to see, the first one might time out, but we should hopefully start to see replies, and that's indeed we have. So we have connectivity from PCD over to our switch. So at this moment in time, although we've got connectivity, we cannot telnet. Okay, so we can't telnet as of yet. So why can we not telnet? Well, we can't telnet as of yet, and let's just prove that first. If I go 192.168.99.1, it's gonna refuse us. And essentially why it's refusing us is because we haven't set up any what are called VTY lines. And these are kind of an old name for terminal emulators to access the switch remotely. So what I'm going to do is I'm going to quickly go to our switch and I'm going to enable telnet. Now again, this wouldn't be something we do on a production network because telnet is insecure. The text goes across in clear text, so if someone was monitoring or using Wireshark to sniff the network, they could potentially see passwords. But for our case here, we're just going to prove that we can remotely log into this switch. So I'm going to say line VTY, this is our virtual terminal lines, and I'm just going to say 0 to 4. This will give me 5 simultaneous, if you like, access to the switch. We only really need the one. And I'm going to say, for example, I'm going to give it the password of Cisco. Just again, we're just testing here. And I'm going to force that the user has to log in. Once I do that, I can close down switch 2 again, go back to my PC. This time I'm going to hit the up arrow, telnet again, and once I do that, you can see it's giving me a different message. It's basically saying open now, and using the password of Cisco. You don't see it repeated back to the screen, but I've just typed Cisco, I pressed enter, and I'm now on this switch. So again, I can use my question mark to start seeing various different options on the switch. So if I wanted to manage this, I could. Okay, I think we've seen a lot of different things over the course of these 3 videos. So again, thank you very much for your attention, and I hope to see you again soon. Thank you. Bye-bye.